So, okay, so after this insightful talk, we continue with Dr. Sibel Adali on community and trust for enhancing misinformation analysis. She is joining us, but online. It's at 3 a.m. her time. So we really want to thank you, Sibel, for your support to our event. Dr. Sibel is a professor at RPI. Her work concentrates on cross-cutting problems that are related to trust, information retrieval, natural language processing, misinformation detection, and social networks. She's the co-author of a book called Modeling Trust Context in Networks, and currently she's the Associate Dean of Science and Graduate Studies at RPI. So she will provide us with an overview on information credibility and its correlation with the veracity of information, particularly in the context of news and social media domains. Dr. Sibel, we're all ears.
Good morning, everybody. Can you see my slides all right? Perfect. Thank you very much for inviting me, and good morning. Please don't tell me what happens. You know, I'm still not on Monday yet, but I'm very excited to talk to you, but I'm very sorry that I couldn't be there today. And thank you so much for the lovely introduction. So I want to talk to you a little bit about the research that I have done in this area, and kind of the lessons that I've learned, past and future. So, as Mariette had told you about the book that I had written, I've been looking at this problem of research of trust before I kind of became aware of how misinformation was being weaponized. So I have been studying trust from a social and cognitive perspective and trying to understand how people use this term in different ways. And then started getting interested in this notion of why we trust information and what kind of factors impact this trust in information. So it turns out that this is a very complicated formula. We may trust information because we use our own judgment and we believe our own judgment, or we may trust the source because the source is reliable, or we may trust the source, being competent or knowledgeable in the field. But often we don't use all these different, formula, but we use different ones in different weight because we find that, okay, maybe I trust my information a lot more, or that this source is too reliable, or maybe I want to use this information to signal my own identity. So that's why I don't actually even care about its credibility. So we use, different factors depending on context, which is what makes this problem a very complicated problem. So kind of this notion of information trust is colors how I look at this problem. And just to show you a little bit more about that, I will tell you a story of just the start of COVID that I wanted to I was about to go to sabbatical, and I wanted to visit with my parents who, I'm from Turkey. So, and I've been trying to tell them to come and visit me while I was going to be in Europe, but my mom told me absolutely no. Before anybody knew it was going to be a big pandemic, but she said that she thought that it was going to be terrible. It was a terrible idea to travel. And I never believed her, even though I had all the information in the world, including information from, the top epidemiology modelers. I did not want to believe it. So she actually had one very trusted source, a well-seasoned journalist that she watched on TV. So it's kind of the moral of the story is that having a lot of information, even good information, is not necessarily sufficient to make good decisions. What we need is trusted information and good information brokers. So this kind of colors some of the information that I'm going to give you, that I always look at this perspective of trust and why we trust information. So there's a lot of research in this field, and it kind of exploded from the time we started doing this work. And, there are many different aspects of this problem that will change, what the results are and how, applicable they are. So, this notion of fake news is very hard to define. Most people will use fake news because that's how you get cited, but information can be bad for many different reasons. So it could be false, fabricated, decontextualized, mixed with truth, many different ways. So whenever people say they are studying fake news, you have to really ask what they really mean by that. And the second thing is that you have to be very aware of how you choose data. The very first paper we wrote on this got massively cited, even though that was in fact the worst in terms of generalizability, because over time we became very cognizant that we have to have good data. And to have some, generalizable results, you have to have some broad data that covers, not just one type of source, but every type of source, so you can understand something about them. And you have to be very transparent how you collect that data and describe the limitations. So the limitations of my talk is that all the work that I'm going to present is based on text. It's going to be all English, and it's going to be based on, sources that are about US news, because that's, the data that I know the best. But it does cover all sorts of aspects. We collect from 500 plus sources. We've been collecting since 2017, every single day. We get about 2 million articles a year. So it's kind of important to at least have some idea of the full spectrum of news and media to be able to have some results. So this was our first important lesson. The second one was kind of trying to figure out, if you have an algorithm that, distinguishes good from bad, how do you label good and bad? One of the things you find, this is something I studied from before, when you try to label articles, it's very hard to get a good ground truth. Again, it may be that you crowdsource, but people don't know exactly what, the topic was, or you try to look at social signals, but there are all sorts of bias and, lack of information at the time, and, the information may be ambiguous. So in general, not only many articles, are not rated or cannot be easily rated. You may not know the truth at the time, right? So, you're looking at how people labeled it then versus now. And the most important thing is that very, very difficult to really label everything as true or false. Many things just don't have a single easy label. Instead, for this work, we opted to look at sources themselves and try to find labels for the sources. So in the US, there's a lot of sources that label, organizations that label news sources as, reliable or not. So we generally look at two classes. We actually have more classes, but I'm going to kind of assume that we have two classes of sources that are largely reliable and sources that are largely unreliable. So, reliable sources are the ones that kind of correct themselves, have an editorial, control, gather and present information responsibly, whereas unreliable is, everything that's not. So, coming back to kind of the main problem that we are going to study right now is understanding whether I can distinguish articles from reliable sources from the articles from unreliable sources. So in this problem setting, all the articles from a single source will have the same label. This is not completely a stupid thing to do because, sources curate information for their audience, so there is kind of a similarity for what they do. But it still is a coarse-grained analysis. When you do this kind of analysis and you label articles this way, it's very important when you train methods, you basically don't just label articles and then take some articles out to see whether you can predict their label correctly, because that leads to all sorts of, overfitting. So what we actually do is we take out the whole source, some set of sources, and then see whether we can actually find out whether those sources were reliable or unreliable based on a set of features. So it's very important when you do this kind of work to do source level splits. Otherwise, you would be just very happy that you have such great algorithms, which is what you see in a lot of the literature. But it's actually not really generalizable at all because it's very easy to get that. So what we try to see whether we can predict articles from unseen sources. So given this problem, we have actually done a lot of feature engineering over the years. We have looked at what we call artisanal features. We have looked at things that make sense for news, 200 plus features. Later on, we of course went to look at embeddings and large language models because, as they became very popular, we had to be published. So we have tried, this problem over very large data over a long time. And we have concluded that, you can only go so far with text analysis. Text itself, will give you information, but this kind of analysis, this kind of algorithms have limited utility. There are lots of problems with it. So first of all, you have to create these, for every single language. And this is not really very practical for especially low resource languages. And, and you have to develop these type of algorithms for every single language. But the bigger problem is that what they really do is they only find true outliers. So, almost all of these text-based methods will basically have the normative, group and then identify the things that are different, right? So they may not be universal from culture to culture. It may not be universal from, let's say, your reliable US sources versus the reliable UK sources, because, the normative features will actually change. So they are not very, general. We have worked very hard to undermine our methods to look at all these types of limitations. And it is not clear that they actually, capture some very general aspects, just language alone. But other problems that we see is that many sources are not easily just reliable or unreliable because contextually, sometimes they are reliable, sometimes they are not, maybe based on topic. They are on some, gray area. So, they don't really tell you how bad they are, right? Because you have a binary feature and it's very hard to find a label like that. So we also find that these kinds of models, over time shift. So, as topics change, the way people talk about them change, these models become less reliable. So because of all of this, we basically wanted to find other signals that were more useful. So that was kind of the title of my talk, right? Since news is consumed and produced for audiences, right, for communities, then we need to understand if we can use that knowledge that the sources feature to understand the news production and news analysis better. So we want to find sources that target similar audiences and use similar language because they want to be understood by the same audience, or have similar stances towards issues, again, for the same reason, whether they would have actually similar factual reporting behavior. So to this, we actually developed new indicators that were much more language independent. So one of them was basically looking at when sources copy from each other. A lot of sources do that to kind of fill the space of 24-hour news. And we can construct networks of copying behavior to find communities of sources. Another thing we did was basically look at whether sources use the same words to mean the same thing. So this is an algorithm my group has developed, where you can look at whether words are used to mean the same things, semantically, and which words differ. So based on this, you can find that the semantic distance between sources' use of language, and we call this the semantic shift indicator. And in terms of the scientific news, we also looked at whether they actually have the similar stance towards similar, let's say, scientific articles. You can also use the same thing for, let's say, stance towards certain political figures, for example, and whether that that there's agreements between those two. So these features, for the most part, are very language independent and much smaller. But using these kinds of features, for example, we've been able to find that copy behavior actually shows us distinct parts of the media in the media that we study. And we can actually take these kinds of similarities and differences to find embeddings of sources, where if you take a source, which sources are similar, which sources are different, and embed them to find a placement of sources that are, similar sources are grouped together and different sources are further apart. So basically, we are trying to kind of generalize the different types of indicators of similarity of sources to get a meta-similarity embedding. So what we have done is we have actually looked at these indicators and looked at how good they are at classification as well as clustering of sources. So we found that we, in fact, do a lot better in classification when we use these community indicators versus just text-based indicators or text and some of the smaller indicators. So we found that we actually do quite well in figuring out reliable sources from unreliable sources, and we actually can get this kind of a model with only 3 months of articles, and quickly find the best representation. But what is more interesting, in my opinion, was that when we use clustering using these embeddings, we found actually clusters of the news landscape, and we can actually find clusters have other meanings. So for example, if we cluster the embedding and then later look at, for example, how the reliability measures have distributed, we find that reliable and unreliable sources are actually clustered together. So in the middle image, you have these pink sources that are unreliable, and then the green sources that are reliable, they're in their own cluster. If you look at for political leaning, in fact, there is also clustering by political leaning too. Right-wing sources and left-wing sources are actually clustered together, as well as sources that don't have political leaning. One of the interesting things we found is that we looked at these clusters as to which words were, for example, most semantically shifted from one of our baseline clusters. So we found that, for example, if you look at these two unreliable clusters that are both purple, the red cluster actually had mostly political terms that were shifted compared to the baseline. So basically, it was an unreliable cluster, but it was a politically unreliable cluster, right? So it was mostly political. Interestingly, the second unreliable cluster, the gray one, was not political at all. And it turns out that that's actually all health-based conspiracy. And the point was that, since they want to sell you, products that they don't want to be political, so, they don't want to alienate one part of the public. But if you wanted to lump them all together as just unreliable, you will actually lose a lot of, fidelity in your models. So by being able to use communities, we are able to find all these latent structures that we can actually take our methods and verify them, and develop methods that basically can make use of this higher fidelity. So basically, that is the message that I wanted to get across, that misinformation analysis is not one size fits all. We need to find methods that can help understand and explain the complex misinformation landscape, because it is, in fact, most complex. But I wanted to say a few words in my remaining a few minutes about the generative AI and how this changes everything, or maybe not. So, we have long talked about information, and we talked about the terms like misinformation or disinformation. One is being that in the disinformation, you are spreading information that is purposefully incorrect knowingly, whereas misinformation you don't know. But when we get generative AI, when things are not, grounded in fact, now what you do have is nonsense. There is in fact a book called On Bullshit that talks about how, the main distinction between bullshit and lies is that in one case you are not grounded in fact and you don't actually care what the truth is. So sorry to say that generative AI kind of falls in that. So we do have to think about how does this change the problem, right? There are many risks of generative AI that, but one of the risks that I see is that we're going to spend a lot of our time in making things, figuring out how believable it is because these papers are coming up, making kind of more probabilistic improvements or, we have some safety features, but that work itself may be very dehumanizing. There's a lot of dangers I see. But as the previous speaker also kind of mentioned, that the bigger danger that I see is that we will in fact not believe correct information. Not so much that we will believe incorrect information, which happens actually more frequently than we think, but we will be unwilling to actually believe the correct information, and we will not know what to believe, right? So the way that I look at kind of the pollution that we see for information is that, we had a lot of these different facts, right? Alternative facts, or people believing in things that are completely incorrect and provably incorrect. But with generative AI, we are going to see more and more things that are kind of completely all over the place, mixing and matching of narratives, things that are not true mixed with true, and continuously changing, untethered from any kind of even persistent narrative. And to me, that's a modeling of, instead of communities, noise. But one thing that I wanted to talk to all of us is that, again, thinking about the fact that, all of this information will be consumed by a group of people, and that we do think and work collaboratively, and that we understand things in this way, communities are still relevant. The information is still there, and the communities are still there. And our job should not be so much worry about, what not to trust, but also to worry about how to find what to trust and how to help people find it. And somebody who studies trust will tell you that generally you have to, you will make mistakes, but you have to find solutions that are long-term, not just one shot. It's not about, looking at a single article to say if it's true or false, but it is in fact finding things that help us understand sources, help us form communities, and help us support communities. So basically that is our task, and that is what I will be working on. And I hope that we can find methods that really achieve this, and also find methods that actually will support rewarding and equitable employment and better social outcomes for everyone, and kind of give ourselves the space to imagine those solutions that may not all exist within the realm of the large language models. So with that, I would like to thank you all. And also, I would like to thank my lovely students who have stuck with me in good days and bad days. And, and the best fun we could have was basically Zooming with some farm animals. But without them, I would not be here. And I thank them for all this work that I have talked about. And I do know that there is a lot of work, but I think that we are up to it, especially those of us in this audience. And if you have any questions today or later, please feel free to contact me on this email. Thank you very much.